are these two triangles similar? Well, first I'm going to look to see, I've got a side angle side situation here, 15, 50, and 12, and 20, 60, and 12, but I notice that the included angles 50 and 60 aren't congruent. So now I'm going to try to go after to see if side, side, there's three sides in this triangle, and there's three side measures in this triangle given. And the trick to do this is to make certain that I organize the side, like 9 is going to be is the smallest side in this triangle. I'm going to try to match it up with the smallest side of this triangle, which happens to be 12. They happen to share the same side. So when I do that, these are the three ratios I'm going to look at. 9 is to 12 on the other triangle, and 12 is the next largest side, and 15 is the largest side, and I'm going to match that up with the smallest, the next largest, and the largest side for this triangle. And I'm now going to check to see if all these ratios are the same. And there are a couple of ways to do that. One is to simplify all these three ratios, and they do simplify to 3/4. Another way to do this was actually to do the division. 9 divided by 12 is 0.75, and they all have the same ratio. So therefore, these two triangles are similar by side similarity. I also checked that to make sure that there's a couple of ways, or more than one way, you could have written this similarity, but I want to make sure that I've said it the right way. So if it's the right way, that means that AB is to AC. These first two letters here match up with the first two letters. And now look up there that AB is 9, AC is 12. So far I'm good, 9, 12. BC is 15, and CD is 20. So 15 over 20, I have that here. So I do have the right ratios, and I do have the right correspondence, and that's key. Now that they're similar, the second question in this problem was to determine the missing angle. So I'm going to move this out of here, and based on the correspondence here, I know that the measurement of angle ABC is the same as ACD. So let's see, ABC, I don't know the measure of that. ACD I see is 60 degrees, so I know that the measurement of the other missing angle is 60 degrees, and I'm going to put that in its proper place just to see what it looks like. So this is a 60-degree angle in here. Next one I want to see is BCA. So BCA, middle, last, and first, would be matched up with CDA. So let's see if I can know one of those two measures. I know they're both going to be the same based on the fact that they're similar. So BCA is 50 degrees. So therefore CDA is also going to be 50 degrees, and I'm going to put that in its proper place as well. So let's see, CDA. Even though it doesn't look like it, this diagram obviously isn't drawn to scale. So I have two angles, and I know that the other two angles have to be the same, and that would be CAB and DAC. And most of you know by now, having done so many different problems, that three angles in a triangle sum to 180. The missing angle is 70 degrees, and therefore this angle here is going to be 70 degrees, as well as the other angle, CAB, is going to be 70 degrees. So I'll put that in there, and this problem is now solved.